All right. Can everybody hear me? Sweet. All right. I guess welcome to Oops, I Built an EDR, an offensive guide to sanity checking your payload. My name is Mike Hedlund. Who am I? I'm a senior cybersecurity consultant for offensive. That just means I'm a pentester for a MSSP based out of Iowa. And I do purple teaming, pen testing, ransomware simulation, red teaming. And then I do a lot of malware development and offensive tool development for my team. I do have a couple of open source tools. My GitHub is there if you're so brave. But before I begin, just small show of hands, who is offensive red team? More than one, great. Blue team? More, okay. This will be good for y'all. And then, is anyone in here sales for an EDR? Okay, good. I didn't have to ask anybody to leave. All right, so for those of you who are offensive, has this ever happened? So, anybody who's ever done C2, offensive payloads, pulled something off of GitHub because they just thought they could get away with it, this is not an uncommon sight. These are both regular Defender. There's no ATP. There's no fancy paid EDRs in this because as soon as you get into testing against EDRs directly, they may not be happy about it because it violates their EULAs. So what does this mean and why do we care? Why do I care? So in 2024, staying undetected in today's world is actually really, really hard. Gone are a lot of days of running Mimi cats with, it renamed. So Mimi dogs doesn't work. Changing a few bytes at the beginning doesn't work. Updating the compile date doesn't work. There's a lot more going on under the hood inside of EDRs and in defensive teams that has progressed over the years. Defensive teams have gotten better. They've gotten more knowledgeable. The average defensive tooling has also gotten significantly better. Even in the last 4 years, stuff that would just work no longer makes my life easy. I have to try to work around multiple different security products often instead of just an antivirus or just an EDR. Firewalls are becoming more of a thing to have to work around for network traffic. And some of this is because over years, pen testers have been harping on blue teams and saying, you need more layers, you need more security controls, you need more visibility. And while blue teams may not get the initial budget, the security vendors see those recommendations and they see dollar signs. And so as a result of that, blue team budgets are getting bigger. Or at least that's what I'm assuming, because I'm seeing more tools. All right, so from the offensive perspective, we need to be more adaptable. We need to be able to test our payloads. We need to be able to know what's going on under the hood and how we're getting picked up so that we can at least try to evade it. Gone are the days of, getting a 10-minute mail account from 10minutemail.net and pulling an EDR trial. Allegedly that worked up until about 3 months ago for several vendors. Having an EDR lab is really good, but it's really expensive. So if I'm a red teamer and I am dropping into client environment after client environment, over the course of 6 months, I might see 8 different EDRs and 12 different configurations of those 8 in different tech stacks. I touched on it, the EULAs for EDRs Most of them now have specific clauses in them that say you cannot reverse engineer our EDR, and that's 90% of what threat actors do. Because if they're going to demand $1 million ransom, the EULA for CrowdStrike doesn't really matter. So testing against an EDR in a manner from the more ethical side becomes somewhat difficult. You can do some testing with your own EDR, maybe you get a demo license, maybe you've got a couple that you manage, or you're lucky to be an MSSP and manage a couple dozen. But for those of us that aren't in that solution or that have those resources, we need something in the middle ground where we can see some of these detections go off, we know what's happening, we can see why our payload's going off or why it's not, and be able to correct those. And public EDRs don't give away what they detect because that's their secret sauce. So, as a result of this, I built an EDR, kind of. I built a logging platform with an agent for Windows that supports detection, and it also supports Yara and process killing capabilities. So, endpoint detecting response, close enough, right? And so, it's not a full-blown EDR. There is a lot in something like SentinelOne or CrowdStrike that they have multi-millions of dollars of development. I have one person in the evenings over 6 months. So why would I bother even building this in the first place? And so part of the reason why this talk is called Oops, I Built an EDR is because a lot of this came about by accident. So I went down a rabbit hole of Windows ETW and ETW-TI, which is event tracing for Windows, and then specifically the threat intelligence portion of that. And a lot of this was invented for error tracing or debugging purposes. But over the years, various EDRs and other security tools have taken advantage of these event feeds in order to perform certain types of detections in a fast manner, or to augment something that the event log doesn't have capabilities for natively. And so where this comes in is the event log actually is populated by ETW feeds. And so if I just look where the data is being fed into, I get so much more data, and I can do so much more with detections, and therefore, if I can do the detections on my own, I can try and figure out how to get around them. And so I wanted something simple and repeatable. I didn't want something that had an elk stack in it. And I wanted to be able to sanity check some payloads. Along with being able to mentor some of my more junior consultants in this is a bad thing. Don't download Bloodhound from GitHub. You're gonna get caught. And so it also helps with purple teaming because it allows me to be much further down in the stack and therefore have a much better understanding of why a detection might work or why it might not work, or how to advise a potential client or a blue team on here's how you can detect technique X or Y. And so like any good red teamer, I'm lazy. And so I went down the road of public tools, free, paid, what's out there, what's not. There is, Elastic Security has an endpoint that is free, it's open source. However, if you were trying to do payload development, it still feeds telemetry back to Elastic. If I'm trying to develop a payload that evades Elastic and then use it 2 weeks later, testing it against Elastic directly while I'm building it will give them what I'm doing, and they may pick up on it before I even get a chance to use it. And so from there, If I'm also using public tools or free tools, I'm in the same boat as most blue teams, or SOCs, or however an org wants to define their security structure. But at the end, I have to be trusting of somebody's marketing somewhere, and I don't like that. I've been burned too many times on promises made by tools and marketing, and doing just enough to say they do a thing or they detect a control, when in reality they're detecting only a very, very, very small portion of that technique. And this would allow me to learn more, be more familiar. Using something like an elk stack on its own to do something like a SIEM and test payloads that way, to look into, can I get around the event logs? Is that going to get triggered? Is it not? Would require an elk stack in the first place. And if the EDR is my biggest target to evade, the event log is probably not where I want to focus. Also, I need an elk stack for that. And so from an offensive perspective, if I'm going to try and evade most places within a security or a secured environment, I need to take into account a few things. EDR, SIEM are very common. EDR is pretty much everywhere nowadays. If you're not running an EDR, raise your hand. No, don't. SIEMs are becoming much more common with prices falling and with rising costs of insurance. And so that's becoming more available. The biggest challenge for SIEMs that I encounter is they exist, but they're not tuned. And so you can do whatever you want in the org, and it's logged. So IR is going to have a great time, but that doesn't mean ransomware didn't get deployed or that the domain was taken over. And then newer tools like Defender for Identity for identity monitoring, which are looking a little bit more past what a SIEM can do and ingesting some of those pieces of telemetry from ETW and doing some correlation between that information and Active Directory. Are starting to come out. They are new and very, very limited. Defender for Identity is one I've played with quite a bit. And when it catches things, it's great. When it doesn't, there's nothing. And so it's very binary on the, is it going to catch an attacker or not? So from my perspective, let's just assume everything. And so EDR is the first line of defense on an endpoint. We're going to ignore the firewalls. So for those of you thinking, but what about the firewall? Let's just assume the user's dumb and clicked a phishing link. So what does an EDR actually give a blue team? EDRs typically provide things like process tracing. They provide certain levels of user activity. They provide more details out of the box than your typical Windows-based SIEM or monitoring via the event logs. And an EDR is inline, it is active, and it's something that I have to actively choose to evade instead of just running something and hoping I don't get caught after the fact. Because that SIEMs are by nature very reactionary. The logs, an event happens, the logs are created, the logs are sent to the SIEM, and finally, hopefully, an analyst gets to see them and can make educated decisions about those events. And identity monitoring is pretty generic out of the box, and even to this day, Defender for Endpoint, other than having about, Defender for Identity, other than having about 4 checkboxes, doesn't have a ton of other controls or other tweaks that you can make. And the biggest limitation for SIEMs is they can drink from the fire hose. There's a lot of data there, but nothing is infinite. And eventually you have to either discard data or just choose not to ingest it, period. And so from all of these tools, where do most defensive teams lack? And so for this, I'm not looking at orgs or companies that have $1 million budget just for their cybersecurity. Anybody who has that already knows what they're doing, or at least they're paying the people, hopefully, enough to be knowledgeable and maintain good security posture. Where a lot of this comes into play is when you get organizations like manufacturing, education, lower sized healthcare orgs, where there's enough money there that you can maybe get to do some of the fun things with SIEM or EDR, but a lot of the budget for something like a full SIEM installation and a person managing it just isn't there. And so they're in this middle ground where they might have tools, but they're not tuned, and therefore they are only useful in an incident response perspective. And they don't typically prioritize tuning them. And so from that, a lot of SIEMs, after they get put in, 3 months later, they're still in that same configuration. Maybe there's one rule, maybe there's 2 rules. I've had many engagements or conversations with SOC managers or with internal incident response, and a question I might ask would be, okay, have you looked at the public GitHub Sigma rules? And they look at me with blank stares and say, what is Sigma? Which makes my life really easy as an attacker. That is an entire set of controls and detections that I just don't even have to consider anymore. And so if they don't even have those, then where are they getting some of these data feeds? Are they even ingesting enough data? Are the group policies even turned on to be able to log some events? And this gets nitty gritty, and there's a lot of ifs, ands, and buts about it, but especially when you're a small to medium-sized organization, feeding data into a SIEM can get very costly. The running joke that I love was last year when CrowdStrike, it was either CrowdStrike or Cisco was re-upping their Splunk license. It was in the nature of billions. And the joke was, are they renewing their SIEM license or are they just buying the company? I think the jury's still out on that one. And so with all of this data, a small org can't ingest it all. So they need a tool, they need something that can sit in the middle and process some of these events, but not host them, not store them, and they don't need the ingest cost that a lot of SIEMs have. And so that gets in, that points us towards the limitations at scale. Ingesting ETW events raw is taking that normal SIEM fire hose and just hooking it up straight to the water tower, or just cutting a hole in the side of the water tower. There is 100 times more data that's coming out of the raw ETW events than you will get out of an event log. And so a lot of adversaries and a lot of pen testers have released proof of concepts for how to detect certain capabilities. But they're designed from an offensive perspective of, we were able to do this because we bypassed a security control here and there's no logging. Well, you can turn the logging on, but it will create 2.5 million logs in an hour. That's not doable. And so where do you process that? This is actually one of the reasons that Defender for Identity exists. And one of the original reasons and one of the original tasks I was looking at was looking at how can you pick up Bloodhound or Sharphound or any other LDAP recon in an environment that may not be able to put in certain mitigations, but they still want to perform those detections. And how does Defender for Identity even detect some of these? Because they're not being stored, but it's being processed somewhere. And so EDRs also ingest this data, and as soon as you get into payload development, malware development, especially on a C2 framework or building your own custom loaders, custom stagers, ETW, kernel callbacks, there's a very large technical learning curve that you have to go down, but ETW is typically the first thing, or is one of the more recent things that you have to account for. And so, if I can't use public tools, and at least for EDR testing or ETW logging, then let's build our own. I'm a slide behind. So yeah, let's build our own. So, but let's set some ground rules. It needs to be easy to use and easy to set up. I don't want to spend 3 days setting up the infrastructure so I can spend 20 minutes looking at LDAP calls. I want to spend 5 minutes setting up and 4 days looking. And so we don't need a ton of fancy features. Most of what we're looking at is, does an event look the way we want it to, or does it appear as a normal LDAP query in this case? So rules are pretty simple. Yarrow works very, very efficiently for does this string exist in or as a substring, or you can do various combinations. And one rule is absolutely no reliance on an ELK stack. For anybody here thinking, wow, they hate ELK. I don't. I actually really like ELK. But for this purpose, I don't want something as cumbersome because I want to be able to deploy this and test it quickly and efficiently. And so the ideal deployment would look something like turn on the server by running a CLI flag, install and run the agent. That could be something as simple as go run a PowerShell script. And once those two things are done, then you should be able to start testing. I did look into public EDR-like tools. I'm not the first one to have this thought, thankfully. But there's some limitations. The OpenEDR is backed by a company. It also involves an ELK stack and is a much more full-featured product. But I don't know where that telemetry is going. The best EDR on the market is actually a GitHub project. If you like dabbling in Windows API calls and C and Windows internals, I highly recommend it. It's a wonderful tool, actually. My biggest limitation was that it doesn't support ETW calls, and therefore is somewhat irrelevant for what I'm trying to look for. And then there was one called WIDS, which is something that I've seen put together, or other tools like it from regular offensive or defensive vendors. So if you have a MSSP who manages your SOC, a managed SOC, managed SIEM, managed EDR, they might do something like this. It won't be this specific, but there are many tools out there that they put their own tiny wrapper over the top of sysmon and OS query, and they call it an agent. And so, what supports ETW? Silk ETW was actually developed several years ago, came out of Mandiant. It is a very good tool. However, it does not, by default, support being run as a PPL. And therefore it does not ingest ETW TI. And so what a PPL requires and why you need it is it stands for Protected Process Light. And what that means is within Windows, it represents an exceedingly high context process. Common processes that run as PPLs have to be signed by Microsoft directly. It's required, otherwise the kernel says no, you can't even launch it. Or at least that it won't load. And so you need a driver, you need a PPL process. Thankfully, Windows gives us the ability to turn on developer modes. And so we can do some of this in a simulated area so that I don't have to submit my sketchy code to Microsoft and have them tell me it's bad. And so, could we sign Silk ETW? Yes. But the biggest issue is it is managed through YAR rules and an XML file. I don't know about anybody else, but I don't like reading XML files or parsing them. So, and since I would have to constantly update an XML file on every single computer, or I would have to update a centralized XML file and then wait for it to propagate after service restarts, that is slow, inefficient, and painful, and not quite what I needed. There is an alternate tool that is designed around research called CLighter. It actually has a lot of cool info, and a lot of the ETW development that I did leveraged a lot of this, a lot of code, or at least examples of code from this tool. But even in the CLighter repo or project, it doesn't, it specifically says don't use this for mass scale ingestion of data. You can feed both of these tools to an elk stack, but as far as updating from an agent, automatic updates, being able to push new configs simply or easily is a problem on its, neither of these tools support that. So finally, I did decide to build my own. Why? Well, because of everything I've already said. I needed a tool. I needed it to work. I needed it to be quick and efficient. And I needed it to be simple. I also wanted to learn more on how ETW events get processed, how that comes in, what it looks like, and how much effort after you get an event does it take to actually derive good data from that event. And be able to start to deploy and start testing within 5 to 10 minutes. So, enter a tool I am calling Panopticon. So, I'm hearing some laughters. The origin for Panopticon is actually from a centralized prison development way back when, but the goal, and I'm stealing just the goal of it, is to be able to see everything from one area. And so easy to spin up, there's no elk stack required, there's no Splunk backend to drain my bank account, there's a device agent, there's a service, you can run it as a PPL or not, it's just a Windows service. There is a kernel driver that you will need if you want to run it as a PPL, and it all logs to a centralized server. And I did write a query process for said events. And something else that is more difficult to process is EDRs are pulling in multiple feeds of data. So from ETW, so they're pulling in LSA logs, they're pulling in LDAP logs, they're pulling in secrets, they're pulling in file writes. And so we want a way to pull all of those in and be able to filter all of them in a fairly easy, concise manner. And so because this is designed for ease and speed, the core of the server is a API-based endpoint with a front end of very simple HTML over the top of it. The backend is actually based in SQLite, and one of the best things for SQLite is it's fast for small sets of data. You can chuck in 1 million entries, and it's fairly okay. You might want to buy a bigger server if you were going to go that big. But for testing, I can feed in 3 to 4 endpoints, a DC, and maybe an Exchange server, and not overload it too much. It is built in a language called Crystal, which is a native binary, it's a compiled language. The syntax is very similar to Ruby, but it's based off of the LLVM toolchain, and so you get very efficient, very fast code as a result. And the agent itself is written in C. Most of the code from the agent is written fully from scratch. Whether or not that's the best design, I haven't figured out yet. But there are a couple of public ETW parsing libraries. Microsoft has one called Crab's ETW. And in the documentation for that library, Microsoft states it is the worst API ever designed around ETW specifically. And I cannot argue with whoever wrote that in the comment. It is actually a comment in the library. So I decided I was going to build it myself, use some of the code that they had, and I was just going to do it on my own, because, come on, it can't be that bad, right? It was awful. But because I did all of it myself and I'm processing it natively, I don't have to pull in any third-party libraries. It's very fast. I don't even have to thread it in order to keep pace with a decent configuration for a Windows workstation or even a domain controller. I was also able to, because I wrote it in C, to import Yara into it as well. And so you can drop a Yara file next to the agent, you can deploy one with it, and it will load and it will process the logs in the Yara rules as its detections. And so because all of this is native C, all the source code's public, I'm actually able to build a static binary using mini-EDR on Linux, so then it is one single file that you can just drag and drop per piece. The kernel, or the kernel driver has to be a separate file, but each individual file that the agent needs is its own standalone. You don't need a entire directory full of DLLs in order to run it. So copy paste is my best friend. And with the addition of the PPL process for the agent, I can also ingest the ETW TI telemetry, or that threat intelligence that Microsoft has correlated a lot of CPU instruction or process calls or Windows API calls that generate specific threat intelligence events. And those are documented, oddly enough, in a Google Sheets out on a GitHub. And so tracking a lot of this data down it's all over the place. So all of this said and done, now that I've gone through a lot of the backstory and the why, how do we test payloads? Well, we set up a Windows VM, or a couple of them, install the agents on it, and we run the server, and then we can test. Nice and simple. So to start with, An example for seatbelt.exe. Seatbelt is a C# tool. It's a post-exploitation tool. It's written in C#. It's maintained, it's part of the Ghost Pack tools, and has been used and is somewhat still used in identifying certain credentials. It's looking for privilege escalation. There are 12.5 modules inside of it that you can use. And so for the sake of screen real estate, I wrote a exceedingly simple seatbelt detection that looks for the word seatbelt. I am a firm believer in the KISS method, and it has never failed me. So when we're ingesting the data, we get a subset of properties from a specific event. And so looking at this, we can see that on the method namespace at the end, there is a seatbelt.commands.command group. This is actually a .NET class path. And since this is being logged to the .NET provider for ETW, this is actually something that we can ingest outside of the agent, or outside of the process itself. So I can run sharphound, or I can run seatbelt over here, and I can do my detections over here on the same Windows box without ever having anything need to make API calls. It doesn't have to leave the Windows box to do the detection. The Yara rules do it for me. And so for this case, the simple solution is, well, I just need to change the word seatbelt. But this limitation requires me to have to, or this detection would require me to have to go and change the source code of seatbelt itself. Because the way that the .NET processing goes through ETW, all of the class items, all of the class namespaces, and occasionally variable names or function definitions end up in ETW. And so in terms of post-exploitation languages, .NET is very, very bad. So another example would be something like Bloodhound. And Bloodhound has 12 different LDAP queries that are very well signatured, and it is easy enough to search for them. But one of the biggest limitations from a blue team perspective for detecting something like Bloodhound is you have to set up either canary accounts, or you have to turn on the Windows event logs that monitor LDAP. And that is a single event that will overtake your entire SIEM about as quickly as your firewall traffic will. And so in order to proof of concept something like Defender for Identity, or provide the same functionality that Defender for Identity has, from an offensive perspective, we just put an agent on the box, it reads the event telemetry, and then it feeds it back to our server, where I don't even have to go update the agent on a DC. I don't have to install anything new on a DC, but I can still get all the telemetry from a proof of concept attack that might be happening on an entirely different device. And for something like this, it doesn't even have to be a Windows device. It could be a Intel NUC or Raspberry Pi stuck behind a TV in a conference room, planted from a physical entry. And then going from that, you can run LDAP queries, you can start pivoting your attack chain from there, and you're not even on their Active Directory network yet. And so this is something very simple that Sharphound or Bloodhound.py leverage a lot, is this object class star. And so here is a good example. You know, we ran it, And here is the event. So we can see object class star, and then there are other pieces of the attribute list. And so we can start to piece together what additionally is getting pulled out. And so while it's not in this screenshot, you can look for things like user enumeration or group enumeration for LDAP queries involving domain admins, or schema admins, or enterprise admins, or any other protected group that most users within an environment just shouldn't really care about, or at least shouldn't care about knowing who's in it. And so, finally, I have a demo, so we're going to pray to the demo gods that this works. And we're going to pray that I have enough cell service and enough phone battery that the rest of this functions. All right. So the first thing you need to remember is I'm a pen tester, not a UI developer. Be happy there's colors. So the chart up top is just a simple donut chart. We can see and dynamically scale some events to see what is being ingested in. We can see .NET Runtime has a bunch. We can see that, I don't know, is that WMI? So WMI has a lot. We can see various types of ETW telemetry coming in, and we can exclude it and not. We can also see some graphs here, or a graph of how much data was coming in at any given hour. And before I move on, I do support Silk ETW for being able to be ingested. That was actually one of my first clients, was looking at Silk ETW and what it pulls in. I don't have any data in here, but the search function works just fine, along with the YAR rules. So if you don't want to deal with the built-in agent or the agent that goes with it, then you can use Silk ETW. But for the agents, or the custom agent that goes along with this, there is a lot of events here. So something most SIEMs have, most EDRs have, is some sort of search function. So there is some level of tab complete. You can tab up. There is negation. There is equals. So if I want to look for, actually, let's do provider name, and where the provider name would contain LDAP. So even though it's a SQLite backend, it's still relatively responsive. It's fairly quick. We can see data coming in. We can click on various events. And we can see that Yara rules coming in matching certain events will show up with the name of the Yara rule. And so if we go into it, we can see what the event looked like, and then where we can move from that. So as we test our payload, we can either write new Yara rules, or we can leverage existing ones that either you have for clients or that you find off of GitHub. And you can see, hey, does this actually pick up something like Bloodhound or various C# applications? You can go further. The sky's the limit at this point. It will natively support any provider name. Once you're a PPL, there isn't a limitation. My current limitation only is that if you are going to ingest the network events, it creates its own network events and then ingests itself. So, but it handles it beautifully. There's just a lot of data to work through. But would rather have the data and parse it rather than not. And so, how refined? I wrote a query language, so not super, but it does support things like and process ID is 4, I don't know. Okay, I can't guess very well, but it does support and or, so you can do some filtering there. So while it's not perfect, it's definitely enough for research purposes for what I'm doing I'm looking for the process seatbelt, or I'm looking for sharp hound, or something like that. And so I did put a little bit of documentation in here. It's not much because the query language itself isn't very complex. It supports all of like four items, equals, a regex, and a negation, and then and or. And so that's where that ends. And then this is the part where it's going to get iffy. Come on. All right. So in order to test some things and to prove some things out, we have proof here. Defender is turned off. So we don't actually need Defender for this, but it makes it very hard if I want to run seatbelt. And I can't actually read that. Does that say seatbelt.exe? All right. Yes. All right. This is where I'm a developer, not an English major. So we can see it runs, but it doesn't get very far. So normally, for anybody who's familiar with seatbelt, this will actually go through and it will look at anything a user has access to and dump it to screen. And if I run it again, it doesn't even run. So the agent on the box is actually feeding in data constantly. And so if we run this, we can see it processes a ton of data and ships it out. It actually, or it also has the ability to kill the process. So if we go back to here and we do actually. So if you do the full colon, it will do a 1-to-1 match. Or if you do the little tilde, it will do a like clause in the SQLite database. So now if we do. So, and we see new events coming in from our local workstation. And so if we look at this top one, you can see there's a seatbelt.exe process. Seatbelt again. Did I? There we go. Okay, there we go, seatbelt, there we go. So now we can see, all right, here's a seatbelt exe for a module being loaded. we can see some more details here about fully qualified assembly names. So this might be something really good for an executable that we're looking for. We know some signatures about it, but it got renamed, or we're looking at a signature that is based off of just enough data, something like a hash or a process name or certain circumstances around it. So this will look at pieces inside of the application itself that are getting loaded by Windows and then being processed, and still be able to flag this. The simplest solution from an attacker's perspective is to not use C#, but ETW goes far more than just C#. We saw LDAP. This is a good C# example. For this case, I would just rename, I would pull down the seatbelt source code and change the word seatbelt to belt seat, and then recompile it, and it would break every detection that this would give me. I would love to show you the agent config. I may have stayed up a little late last night, and I borked the UI. So, rain check on that one. All right. I love PowerPoint, it's great. All right. And my demo actually went really, really well, which I was not planning, so I prepared a bunch of screenshots. So hopefully for anybody in the back who couldn't see the live demo, this gives you a little bit more idea on kind of what I was doing in some of these cases. You can search for process IDs. Here's object class, looking for just that. And so things like this allow you to look for more than just what's in the current YARA rules. So I can look for new things. I can look for slightly variations of LDAP queries or process names. Event data. This is more LDAP direct, but this gives the full page. And so why did I pick ETW? Why not look at the in-process DLLs like all the other EDRs do, and like public paid-for EDRs do? The biggest thing is that ETW, while it can be patched, if you want to know more about ETW patching, come find me later. It's fun and great, but it isn't device-wide. And so needing to do patching of ETW works in process. So if I want my one single process to evade ETW, I can do that. I can also do that with all of the EDRs, DLLs that are loaded. Anything in a process that I control, I have control over, because I control the process. And that goes for EDR DLLs. So if CrowdStrike is putting a DLL in my process and I control it, I can just remove it. And if I can do that, then it has a lot less insight. But what I can't do from a user perspective is I can't remove ETW from other processes, at least not very easily. And I can't do that for devices across the network. And so it's a very good foundational piece to ingest data from that can't be easily modified by an attacker, versus a DLL that's loaded in userland is trivial for an attacker to remove. If I can do it as a single person, then I guarantee you Lockbit can do it too. And so how do we get around this? Well, you be smart. You change your payloads, you change the word seatbelt to belt seat, you recompile things, you change up the order in which you do things. It used to be that you could put a for loop randomly in programs that would affect enough of the timing and or logic that ETW would actually break. And some of this does still work. I'll pick on Defender for endpoints since they're my target today, apparently. If you wait long enough, you can actually get around Defender's ETW calls. And so they're still ingesting all of that ETW data, but if you space out all of your Windows API calls and say run an exceedingly inefficient Fibonacci sequence in between each, just looks like you're a college student doing basic programming. Which works really well when you start making network calls and LDAP queries to a domain controller. And finally, the best way to test your payload is to know exactly what it does and what is looking at it. And then from there, you can kind of separate those two so that you don't do the things that what's looking at you cares about. In payload, patching ETW calls, patching anti-event write are useful. That gets very technical on Windows API calls. Come find me later if you want to know more. Hardware breakpoints are also used for ETW as well by attackers. So all of these things can be leveraged as an attacker to evade or work around ETW, but it doesn't mean that ETW is entirely useless from a detection standpoint, or that I just don't need to worry about it anymore. Panopticon is not an add-on or a replacement for your EDR or SIEM. Please do not pull this from GitHub in 2 weeks or whenever I actually get it made public and say, great, I saw this at SecretCon. We don't need an EDR anymore, right? So please don't do that. And then if you're going to deploy this in a massive org, as in, and I say massive, I mean more than like 15 boxes, remember SQLite is good. It's not that good. It's designed for research purposes for the most part. Future plans would be write better documentation. I would love to add in process DLLs to simulate a lot of the existing EDR tools and what they can do. In with that, I want to put it in an AMC because that's a very .NET based, very PowerShell based detection for string based, and it's actually becoming very obnoxious when I want to use PowerShell. So I want something that I can test a little bit more regularly with. Kernel callbacks are the other aspect to ETWs that EDRs have started implementing very heavily. CrowdStrike started a couple of years ago, and unless you are actually in the kernel itself, you can't unload these. And so that sounds like information I want to see. Potentially make Postgres an option. Maybe, maybe not. Maybe a device GUI. Probably not. And this is a tool I do want to push open source. And so at some point within the next month, I'm going to push it open source. So that is my GitHub. Please feel free to take pictures if you so desire, or come ask me for it later. Finally, questions. I actually hit an hour, almost on the dot. So I'll give whoever's after me time to prep and get their stuff ready. I'm going to step off, so come find me if you have questions over here.